So, good day everyone. Today I'll be discussing board work problems for enhancement for midterm. Yeah, so let's start. Reciprocating air compressor has a 7% clearance and discharges 65 psi air at the rate of 48 IBM per minute. Ambient air is at 14.7 psia and 65 degrees Fahrenheit. The polytropic exponent is 1.33. The mass of air that is compressed each minute is most nearly blank. So, other choices. Well, for the given clearance, 7%, which is equivalent to 0.07, P2 or discharge na pressure na 65 psia. Then ito ang P1 or ambient air uh, suction pressure, which is equivalent to 14.7 psia. Yeah, air delivered 48, and then itong polytropic exponent, which is equivalent to 1.33. Okay, so for the solution, compute sa nato ato ang compression ratio, which is R sub P is equal to P2 over P1. Substitute lang nato na sila. So naa-din tayo 4.4218 na compression ratio. After that, isolve na ito itong volumetric efficiency, which is 1 plus C minus C over 4.4218 na compression ratio. Raised to 1 over n. Alala na siya. Solve na ito na siya una, nga tayo 3.06. And then after that, ito ang volumetric efficiency. 1, substitute lang 1 plus 0.07 minus 0.07 times 3.06. Natay volumetric efficiency equivalent to 0.856. Then after that, makompute na ito ato ang actual air na compressed. So, air delivered over volumetric efficiency, which is 48 over 0.856. So, compressed air will be 56 IBM per minute, which is letter C sa ito ang question. So, next. A liquid-dominated geothermal plant with a single flash separator receives water at 204 degrees Celsius. The separator pressure is 1.04 MPa. A direct condenser operates at 0.034 MPa. The turbine has a polytropic efficiency of 0.75 for a cycle output of 60 megawatt. What is the mass flow rate of the well water in kilogram per second at 204 degrees Celsius? So, ano ito given? Given na siya. Yeah. So, for the solution, since nato ito given dira, palitan na ito itong x. So, 870.51 HF minus HF. So, 870.51 minus 770.38 divided by 2009.2 natay x na equivalent to 0.0498. Next, ito na ito ang ito tawag. Wait. So next, pangita na ito ang exit enthalpy, which is H2S is equal to HF plus XS HFG at 310.4 plus 0.829 times 2,328.8. Natay it will be equal to 2,241.5. And next, it's ano na to, actual turbine exit. So it's equal to H1 minus H2 over H1 minus H2S. So 2779.6 minus H2, 0.75, 2779.6 minus 2241.5. So shift solve lang na siya na type H2 na 2376 kilojoules per kilogram. Para sa itong work turbine, minus lang na ito 2779.6 minus 2376 at ay 404 kilojoules per kilogram. Since ito ang X na to is 0.0498, i-multiply rin nato na siya so na makakuha ta og 20.1 kilojoules per kilogram. Para sa itong mass flow, divide na nato ato ang i-divide na itong 60 megawatt to watts. So, may mo siya 60,000 watts divided by 20.1. Narin tayo answer na 2,985 kilograms per second. Since wala man siya choices, tapos ang letter A ang pinakadool, so mga itong pilian. So, ang final answer will be letter A, 2,933. So, next. The gas density of chimney is 0.7 kg per cubic meter and air density of 1.15 kg per cubic meter. Find the driving pressure if the height of chimney is 63.71 meter. For the given, natay density sa chimney gas which is equivalent to 0.75. Density of air will be equivalent to 1.15. And then ito ang height which is 63.71 meters. So for the solution, delta P is equivalent to density of air minus density of gas times gravity tapos height na yan. So substitute lang, 1.15 minus 0.75 times gravity, 9.81 times height, 63.71, we will have an answer of 250 Pascal. Convert na to into kilopascal by dividing it to 1,000 at 0.25 kPa, which will be letter B for this problem. Yeah, so next. Find the work process for a helium gas at 20 degrees Celsius. So for the given, temperature is equal to 20% at 20 degrees Celsius, which plus 273, which will be 293 Kelvin. So specific volume, specific gas nato for helium is 2.077 kilojoules per kilogram times Kelvin. So para sa solution na to, for ideal gas, PV is equal to RT. Since natay R of T, you just substitute it. So 2.077 times 293. Natay answer is 609 kilojoules over kilogram. Wait. So muna siya. The final answer that will be letter A for this question. So next. A steam engine with bore and stroke of 250 mm by 450 mm rotates at a 250 rpm. If the mean effective pressure is 400 kPa, what is the indicated power developed in the cylinder? So, yan siya problem. Natin bore na D is equal to 250 mm or 0.25 meters. Ito ang L na 450 mm, which is equivalent to 0.45 meters. RPM, which is 250 RPM. And then ito ang effective pressure, which is 400 kPa. Yeah, so for the solution, solve na to una ang area, which is area is equal to pi d squared over 4. That's na amatay d. So pi times 0.25 squared over 4. Naatay area na 0.04909 meters squared. And then, para sa to indicated power, naatay formula nga 2 PLAN over 60. So, naa naman tayo area, substitute lang. So, 2 times 400,000. Ato ang KPA, i-convert na to Pascal. So, na 400,000. Ato ang L na 0.45. Ang area, tapos itong RPM. Divided by 60, para mga ito ang RPM. So, very easy lang na ito answer na 73,635 watts. Divide nito siya sa 1,000 para may mo siya og kilowatts. So, natin final answer nga 73.63 kilowatts, which is letter B. So, ang answer ani kay letter B. So, very easy lang kayo. So, yeah, that is all. Thank you and goodbye.